cakes and breads. And around noon, we will have a light lunch available, just so you have some idea what we're going to do. I'm just going to quickly thank Jim Rao, Natalie Karras, Camp Lawrence for providing the facilities, Brian Mytol, Sandy O'Brien, Rich Herr, Nancy Satterley for donating the coffee from Lifestyles Restaurant. I'd love to speak a lot longer, but I think I'll just turn everything over to Brian.
Well, I really, for most of you, Dr. Wilhelm really doesn't need an introduction, but he is instrumental in forming and the Conservation Design Forum of Chicago, Illinois. He's a world-renowned botanist, also the author of Plants of the Chicago Region, and claims he's a botanist, but I think he's far more than that. I think he's an environmental scientist that has a very important message to convey. So I'd like to present to you Dr. Gerould.
Some of you may be old enough to remember Dr. Robert F. Betts. And Dr. Betts died just a few weeks ago of complications from prostate cancer. And I don't know, for those of you who do not know Dr. Betts, he was one of my early mentors with Floyd Swank and Ray Schulenberg, and we would go botanizing at Clark and Pine and Clark Junction and Griffith Prairie and all those things in the old days. But it was pretty sad to hear that he had passed away, because now there's Ray, first Floyd, Ray, and then Dr. Betts. And they're the three people who, in the 60s, began all what we're thinking about today, and are the ontogeny of all the thoughts that have been born out of that era, when those three guys in particular, at least in the Chicago area, began thinking of the kind of things that we think. It was Dr. Betts who discovered the concept of a cemetery prairie. Dr. Betts actually was an organic chemist who became interested in plants. He was a child of Bridgeport, and just like Mayor Daley, and met Floyd Swink and learned that there was more than one kind of Asclepias. This was stunning to an academic, PhD academic at that time, and that stimulated him to learn plants and learn them quite well, and then come to understand the prairies. Well, one day he discovered out in a cemetery a little prairie plant coming up next to a gravestone marker. And he thought, well, isn't that interesting? Here's an old cemetery with Kentucky bluegrass all around, but there's a little prairie plant coming up there. So he said, what happens if we don't mow the prairie? Maybe there will become prairie around. Well, it did. And so Vermont Cemetery Prairie, for example, over off of 41, was this kind of prairie, and he discovered the cemetery prairie. And he went to the cemetery boards, and you know, cemetery boards are just folks who try to take care of the cemetery, you know, keep it clean and keep it mowed and keep it respectful. And he would inveigle them in, charm them in, talk them in his ineffable way, inimitable way, to stop mowing and start burning some of these cemetery prairies. Well, that led to a whole phenomenon of people going out and looking for cemetery prairies. One day, he was in one of these prairies in Illinois that he had saved, not too far from Champaign-Urbana, where he would go out long before it was popular, long before even people were saying the word prairie, other than meaning simply a vacant yard somewhere in Chicago, around 119th and Torrance or something. That could be a prairie in the minds of a lot of Chicagoans. But he would weed. He'd take his shirt off, and he would wear a long, wide-brimmed hat, and he would just pull weeds by himself in the prairies. Nobody to notice, nobody to say, good job, Bob, none of this stuff. Just on his own, on the weekends, he would pull weeds in the prairie, these cemetery prairies, because he loved them. He loved the prairies. He loved them the way Ray Schulenberg did. And one day, then, this professor, I won't say her name, but she was bringing a bunch of students out with their collecting bags, and then going into the prairie and started collecting prairie plants, because these were botany students at the University of Illinois. And this appalled him, because you could get all those families and more along railroads, just with weeds. And so here she was bringing these students to a prairie that he had helped save, spent time and energy and life force getting the cemetery board to stop mowing and start burning and ripping off all the prairie plants so they can put their collections in the University of Illinois Herbarium. Well, he looked like a weeder, you know, somebody who just weeds in a prairie, or weeds in a cemetery, so she gave him no regard. And as she was walking unceremoniously by him, utterly thumbing his nose at this lowlife that had nothing else to do in life but pull weeds, said to the students, "And here is Enothera biennis." And Dr. Betts looked up from under his hat and said, "Oh, well, no, the thing is, I believe that's Gaura biennis," having corrected her right in front of all those students. Oh, he was upset, but he was a gentle man and didn't chastise her at that time, but he told the story later. Anyway, that's Bob Betts. Well, that's among the many aspects of Bob Betts on whose shoulders we stand today. May God rest his soul. And it will. Anyway, I've just been down in Brown County, Indiana, looking in a woodland. And what we're finding in our woodlands today, as we've been finding since a long time actually, is that they are gone. They have the spring flora, but they have lost all other things. And I'll explain to you why and what we must do about it. By explaining a little paradigm, you know, how many of you have heard of E.O. Wilson? He's the famous ant biologist, but he's also quite a philosopher. And he actually did his PhD on the genus Lasius, a genus of ants that's pretty common here, and which are some fairly conservative species in northern Indiana, actually throughout the Midwest. Did a very beautiful job on the genus Lasius. And but he wrote a book called Consilience. And in this book, Consilience, he talks about how in nature all things living together are working together, or to translate from the Latin, consilience, jumping together, if you will. How things are supposed to used to jump together is, I'll draw an example of a Valparaiso moraine type area, maybe along a river where there's some outwash, okay? Just so in cross section. So you draw, like here are the high prairies up on the moraine. I am not an artist. If another person who passed away probably around 1976, that's been a while, was May T. Watts. And she wrote the Reading the Landscape of America, which you've not read that, you should read Reading the Landscape of America. It's a delightful book. Her drawings were so exquisitely able to teach you things, 1,000 words for every picture, you see, in her book, wonderful book. Anyway, May Talgard Watts, a child of the University of Chicago, you know, grew up in the Henry Chandler Coles era and that kind of thing. What a wonderful lady she was. I met her briefly. Here's the prairies, and then here's the moraine. Here's the moraine, and then the high ground, which is flat and mostly with prairie, and I'll tell you why. And then there were the bluffs that went down into a stream dissection. Then there was some low ground along the stream, then there was the prairie stream, say the Calumet River or a deep river or something. So here's like a little river, a little stream. Here's the prairie. Sometimes along streams, in the larger streams, there's a layer of outwash, sand and gravel mostly, that's along the stream where it was a stream that the glaciers or the outwash had moved, would create these areas of sand and gravel that cut down through the moraine and leave this outwash of sand and gravel. This is a kind of morainic till back under here, but this is outwash, and then here's the low area along the stream. Now, something you should know about water is that we get about 37 inches a year, roughly. Let's say we get, that's an easy number, because that's 1 million gallons per acre per year. If you get 37 inches of rain a year, that's 1 million gallons of water per acre per year that fall on the ground. So if you have a quarter acre lot, that's 250 1,000 gallons of water that fall every year on your property. The current doctrine, of course, is to collect that water, turn it to filth in some sort of pipe or detention basin or ditch, and send it to New Orleans dirty. At the same time, I drove up 700 North Road and all these high-end lawns out here with their drug-dependent rugs, lollipop trees, and poodle shrubs are turning 1 million gallons of water per acre per year to hot, poison-beridden, chemically-beridden filth into the rivers and sending it to the people downstream. And then, since we evaporate 1 million gallons of water per acre per year, 37 inches a year, that's the Eastern balance, and we send almost all the rain away, we have to mine water out of the ground to keep the land wet. Historically, the rainwater didn't go away. It fell down, worked throughout the nice, tilthy soil, and came back again through life itself, through the living things, through plants and animals, either in the form of carbon dioxide or water. But that was the transpiration and respiration, all that went on where the rain fell. It was in complete consilience. It came down and went back again up. Our whole doctrine has changed from one of receive, nurture as a resource, and resurrect, to collect, convey, turn to filth, and discharge. That is the current doctrine, and that's why we have so much trouble. That's why in parts of Illinois, west of the moraine, and south of the moraine in Indiana, you have towns that are selling 30-year mortgages with 12 years of water left in the aquifer. We have rules and laws and strictures about 100-year floodplains. Don't want to build in those because you could lose real estate value if the house floods. But we do not have any consideration of the fact that we have no water left in our aquifers. And the water we get as a resource from the atmosphere is being turned to filth and sent to New Orleans, where they don't need dirty, filthy water in ghastly amounts. When I was a little boy along the Gulf Coast of Florida, there were fishing villages all along the coast of Florida and Mississippi, past the Gula and all that area, Biloxi and Pensacola and Fort Walton Beach and Destin, one of the luckiest little fishing villages in the world, they said that Destin was. But what we have now, this is all our filth from the entire Mississippi watershed, all that falls on the agricultural land, all the drug-dependent rugs, all the stuff, all that water is conveyed down the Mississippi River, and there's one massive bowel movement in New Orleans whenever we have a rainy season. Now most of the fishes of the Gulf of Mexico are dead. All that monstrous amounts of fresh water convulsing at one time into the marshes and estuaries put too much fresh water into the estuaries. We're losing estuaries, about 40 to 50 square miles a year of the spawning grounds of the Gulf. If you look at an old map of the New Orleans area, it looks like a fecund, rich land of wetlands and swamps down south of New Orleans and east of there. Now, if you look at a Google map, you go home and Google on your internet thing and look at New Orleans area, it's necrotic. You can see that it's almost all eaten away and gone. The fishes of the Gulf of Mexico are dying out, and the fishing villages are given way to condominiums, which now are building tall buildings on the south side of U.S. Route 98, so the little towns that used to have all public realm along the south side of U.S. Route 98 along the coast, and if you look out into the Gulf of Mexico, now have to look at timeshare condominiums that shade the little town, and the little towns can no longer see the Gulf of Mexico. And rich people from Chicago fly either Delta flights or Northwest flights down to Pensacola, stay in a timeshare 15 floors up, look out at the Gulf of Mexico. I guess that's what they have to do. That's what they're spending all the money to do. Maybe they can go swimming on the beach, but the beaches are all washing away because the dunes are gone. So they have indoor pools, some outdoor pools, but they can tell they've been in Florida because their visa receipts say so. There are consequences for disobeying the rules and the laws of water. Water is a non-compressible resource without which we cannot exist. The rain used to fall everywhere. If you had 37 inches of rain, and it would fall on a square inch, there's a column of 37 inches over every square inch. The way nature handled that water was every square inch received the rain, an inch at a time, and nurtured that rain, and it was part of the life force of the indiment of the earth. And back again there was the resurrection of the water. It's now quite different. The rain that fell here in the prairies went right away in the ground and stayed there. It had nowhere to go. Oh, it would slowly but surely creep laterally. The rain, always the first thing that happens to water when it goes into the ground is to go right away laterally, with the vectors pulling down, but always laterally toward the invert or the base of the stream or the moraine or valley, wherever it was going. So the water table reached itself, and always the water going in like this, moving, taking decades, if not hundreds of years for this water to get to here. Now, 1 gallon per minute coming out of the seat down here, 1 gallon per minute, take a milk carton, a gallon milk carton, and pour out, take a whole minute to pour that out. 1 gallon per minute coming out of a seat to feed to the river is 520,000 gallons per year. That's half the annual rainfall on 1 acre. So when we put a ditch or a storm drain or a farm ditch or farm tile and are dewatering even at 1 gallon per minute, it is a catastrophic rate of discharge. It cannot be replaced. 1 gallon per minute is catastrophic if it's discharged on the surface in the wrong way, or even in a farm tile the wrong way. That's why Newton County, how many of you know where Newton County, Indiana is? That was right over here on the Illinois border, on the Kankakee, in the Kankakee Valley. That was the last county in Indiana to be drained, because it's so sandy and so wet and low. It's the first one to get agriculture, irrigation. Old guys start forgetting stuff. Irrigation. And now irrigation, of course, that's the death knell of agriculture. Now you're getting irrigation in the morainic country. You can go to the lake plains and the moraines of Illinois and Indiana, and you will find expensive irrigation systems. That's a whole other study, a whole other discussion, is the unsustainability of our agriculture. But at any rate, an airplane pilot who's flying an airplane that has a stall speed of 110 miles an hour, he could be a really good guy. He goes to church, doesn't beat the wife, doesn't kick the dog, helps the kid with the math homework, all these things, but if he takes the plane to 109, he will die. Not because he was a bad person, but because he broke a law, a natural law. We're breaking natural laws by dewatering our land at the rate which we water it. This is Deuteronomy, if you will. So the rain would come down and go in, and always in. We see, I was talking to a little girl in 3rd grade the other day at a Princeton Junior School in Princeton, New Jersey, and I showed her my hand lens. And she said, "Oh, can I look at your this?" And look at it. She was like, "Can I see your tooth?" And she looked at my tooth. She said, "Oh, it's big." And she said, "But it isn't really big." She said, "I guess it's just a different point of view." And so she understood that almost all things, depending on the magnification and scale at which you see it, are all things in nature at a scale that we cannot see or perceive. So the fact that a square inch seems small to us is huge for ants and thrips and beetles and soil fungi and all those things. That little square inch is a world unto itself that needs to be nurtured and cared for. It's just that we can't see it at the scale at which we live, which is 6 feet high, more or less, 5.5, with eyes and pupils that have a certain relationship with light, and with minds that are infinitely ignorant. This is the scale at which we see and observe. So, all what is happening, the rain would come down and be nurtured where it fell, come back out through. I'll explain how. But the prairie had in it bunch grasses. Oh, they were lovely bunch grasses, you know, like northern dropseed and little blue stem grass, big blue stem grass. And if they were burned, if those bunch grasses were burned every year, they could every night bring in condensation water. Because the water would condense on those cool green leaves, all the fresh green herbage of the season. And that water would condense and move in sometimes millimeters a night. The agriculturists have shown that, for example, if you put a clear tarp or something over a field at night of corn or bean or some crop, that the productivity drops in half because it doesn't have access to the dew and the water that moves down the stems, even on those kinds of plants that are not bunch grasses, into the soil. So we were raining 37 inches a year, evaporating 37 inches a year, and extra water from the night air that meteorologists and hydrologists can't measure were going into the ground. This is how in the Dakotas you can have 25 inches of rainfall, 40 inches of evaporation, and surcharged water go into the prairie potholes. This is immeasurable. But in a healthy system, this is the way that life could pull water from the air. This is why on June 15th, the lawns, these drug-dependent rugs, that have been unceremoniously rolled in over clay or mowed to the inch of their lives, will start shutting down on June 15th, being brown, and there'll be a tendency to want to irrigate. The very same prairie next door, which is being burned, is starting to bulk up. It knows no drought. A healthy prairie knows no drought in the north temperate zone, where we have the stochastic disposition of thunderstorm and the like. Maybe they will come in spurts, every so often, but that might be 3, 4, 5, 6, 8 weeks at a time. We don't get it. This is undaunting to a prairie this healthy, because it can handle water without rain. It was built in. Somebody far wiser than we figured that out long ago. You should know, however, that in 1874, a fellow by the name of Amos Sawyer published a paper in the Transactions of the St. Louis Academy of Sciences, within which he tried to explain, quote unquote, the reasons for climate change in Illinois. No one had argued that climate change in Illinois in 1874, but they were curious as to why. Today we argue over climate changing because it bothers the corporate people and our way of life and the way we've become accustomed to things, irrespective of the realities. But Amos Sawyer was untroubled by big business at that time in politics, and so he was struggling with others to figure this out. And he concluded that it was what he called the aqueous agent, that all the farm tiles and the ditches that were going into Illinois at that time were dewatering the land. There was no water in the surface, in the crops, on the ground, to move up through evaporation and feed the thunderstorms that were coming through, feed the weather systems that are coming through, and drop again rain. Sort of like in Florida, when I went to Florida State, at 3 o'clock, there would be a thunderstorm come through, and it'd last about 10 minutes, move along. You don't get that in Florida anymore. Florida's drying up as well. Because you have to have that kind of rain, you have to have water going out of the land. When my father was a pilot down in pilot training down in Bartow, Florida, in 1955, 54, they flew the old AT-6s or T-6s, and they would fly up around Polk County, Florida, and they would have to wear the Mae West in Polk County, Florida, because if they went down, they could drown if they didn't have the Mae West on. When he came back to retire down in Polk County in 1975, he was stunned and aghast that Polk County had dried up. And there was no water left, hardly in the Peace River. There was no sheet water left in Polk County. And the phosphate mines and the lawns and the swimming pools and the golf courses had completely dewatered Polk County, Florida. And now, since there was no groundwater, the ocean, the Gulf of Mexico and the salt's moving in under the state and that sand and polluting the wells with salt water. Same thing's going on everywhere where we neglect water. So Amos Sawyer then was concluding that the loss of water going into the atmosphere on a regular basis due to evaporation was leading to the change in climate. The Illinois River at the time of settlement, done in a study by Harlan Barrows in 1911, noted that the discharge of the Illinois River, which drains more than 40% of the state of Illinois and part of Wisconsin, had negligible discharge into the Mississippi, except during snowmelt, early spring snowmelt and rains. So they would get sometimes a lift at Alpha as high as 12 feet. So the prairie streams, and the Illinois River was a great example of it, like the Calumet, was a stream, the principal flow of which was fed by just constant seepage from the hinterland. Constant seepage coming out of the banks. Seepage you could scarcely see in the Moraine country in those prairie streams. Now, if water fell on the outwash area here, there were also little bunch grasses, but they were mostly sedges. In any event, and I'll get to that in a minute, water would go in and then move a little faster. It moved a little faster in the outwash. Water moved a little faster because that's sand and gravel. But it'd go in and move on, and then that would actually come out sometimes and form what they call fens or springs. Not just seeps, but fens and springs coming out of the outwash area. And that was usually pretty calcareous and that sort of thing. Water coming out at a constant temperature, constant chemistry, and constant rate. Very wonderful water. And of course our fens, when the water's healthy, has a dream amount of diversity, just the way our prairies did, because of all the stability of the system. Why were these sedges? In most cases these were sedges because we had on the outwash area trees. I cannot draw a tree all that well, but this looks more or less like a tree. And there was a tree here, like that. Maybe might even be here and there a tree here. And underneath the tree, out here, you have a 10,000 foot candles of light out here in the prairie. There was 10,000 foot candles of light driving the life of the prairie. In other words, every leaf blade of every one of those grasses was a photoelectric panel. You know, photosynthesis is how that works. So that converts light energy into organic chemistry energy. The ATP upon which we live, you see, is born out of that sunlight energy from having eaten that was converted by photoelectric panels on the grasses into food, if you will. 10,000 foot candles of energy driving this system. We may be having here 10 foot candles. We become cave dwellers. Little Ojibwe girls and Potawatomi girls and boys, when they would be out in the prairie, their little pupils were grown from generation to generation. They lived their lives outdoors. Their pupils were tiny and small, and they had great depth of field, and they had sharp images. They could see. We have no knowledge about what seeing is today. We become cave dwellers, living in almost no light at all. Not that our pupils and our irises and our retinas are any different, but there's been an acclimation as we grow older as children. Richard Louv talks about in his book, The Last Child in the Woods, all of the syndromes that can be associated with children who don't play outdoors. When I was little, the big thing we did was, what the parents would say was just go out and play, or we just went out and played, and the only thing we ever came in is whenever it got dark. Or maybe you had to eat, or something, or had to take a bath, or something horrible like that. But we played outdoors, where there was light. We were people of the light. Our people were people of the light. A lot of y'all can remember that. Now, in order for kids to play, the park district has to come up with 1.5 M and go out for an expensive contractor and landscape architect and engineer and architect and a bunch of other people to plan a nature center where you can go in and study snakes that are shedding skin and stuff and look at turtles that are pathetic in the dark. So with the progressive increases in nature centers and nature museums has been a correlative increase in nature deficit disorder, as articulated by Richard Louv in his book. The best way for a child to learn, I believe, is to go out and play. Just play and just mess around. Beat something with a stick. Just look at stuff. Mess around. Outdoors.
That's what we did.
That's what we did. Just play. That's how you get your head on right. Then you get to be an adolescent and start discovering things that are unrelated to that, in a way. But by then you've played. You've discovered. Your love of learning is still there. Every child of the womb is born with a love of learning. I believe that there's very few things really as a dull child. I think we killed them in second and third grade somewhere along the line, killed that love of learning. I think if we just let them learn, they will learn at their own rate. They will demand to know, and as long as we're there to answer the questions, they will be bright kids one day. We don't have to pass them through first and second grade according to some preconceived syllabus and all that other stuff. Oh, don't get me going on that. But so you have 10,000 foot candles out here, all right? There's about maybe three, in this part of the world, about three, because we live in the temperate zone, about 6 months of growing season, and all strong photoelectric energy. You can put about 3 to 4 tons of fixed organic carbon in the form of root mass below the ground every year, of which, depending on how wet it is, a great percentage of that will oxidize and go back out as CO2 and water, you know, as the bacteria work on it and it goes back out. So the carbon dioxide and water that were fixed in photosynthesis and the photoelectric panels are now in the root system. As those root systems die, they go back out to CO2 and water, back out to the atmosphere. It's a wonderful cycle. Every breath you take is a resurrection of that energy. Carbon dioxide and water, that's the light. And the light and the energy in that light is your life. And that's what it is always in the soil and in the plants. Now about a percentage of that really stays in the ground as soil organic matter. You know what that is? Or soil organic carbon. That's the deep mulch. A gardener knows who is planting annuals that every year you have to keep the good soil tilth up. You have to keep mulching in there. So we could put our compost pile, we stir it into our vegetable garden, we grow vegetables. Nature is not a garden this way. Nature is a perennial system. The only way to get deep mulch into the prairie is for roots to grow and die and not oxidize completely. So that root channels and the soil organic matter can keep that water moving in, and the colloidal fraction of that soil is able to hold nutrients and move water through the system. So there's a salubrious relationship between nutrients and water, always there. When you don't, simply not burning a prairie can result in the same kind of loss of production that you would get from moderate to heavy grazing. Because by not burning the prairie, you have a lot of photoelectric energy that isn't being optimized in a system that was since thousands of years dependent upon that energy. And so, by not burning a prairie or by grazing the prairie, we are really depleting this soil organic carbon. That's about, in a strong morainic prairie, that's about 18 to 20,000 kilograms of root mass per hectare. That's a lot of root mass that's produced that's in that prairie, about a third of which is dying every year. Corn roots will generate about 800 kilograms of root mass per hectare. Bean, 300 kilograms of root mass per hectare. Bean and corn cannot possibly produce enough root mass to keep up with the oxidation rate of a tilled soil. In fact, Purdue University, down here in Lafayette, Indiana, did a study of the land that was in CRP from 1980 to 1990. There were 19 million acres. And you know how CRP, it stays in the grass for 10 years, and then if the farmer doesn't get the CRP the next 10 years, he tills it up and We start all over again. Well, within 30 days of tillage, that first tillage, after 10 years, there had been an accrual of about a ton of organic carbon per acre per year over that 19 million acres. About a ton net gain of carbon sequestration, if you will, over that 10-year period. Per year, a ton per year. Within 30 days of tillage, they had lost 90% of that accrual, and within 90 days of tillage, they were back to net loss. Because
What is CRP?
that's the Conservation Reserve Program.
Oh.
You see, right now in Iowa, they did a study, and if you don't include all of the subsidy, the inputs to agriculture, the profits would be about 2 to 4 cents per acre. Agriculture is a monster welfare program. Monster welfare. Most of it going to big agribusiness. It's an Enron that the likes of which, it makes Enron look like a Kinderspiel in terms of the corruption of the fake money in our agricultural system and the fake economy. It's mind-blowing. It's a really good, the CRP program is a really good program because it prevents all that loss of organic carbon and starts to restoring a little bit of soil. So while it's in CRP, the rain can go in. The floods of 1993 happened not because we had a lot of rainfall, but because the soil organic carbon in Iowa soils is down to 2%, down from 5, 6, 7% organic carbon in the soils from what it was prior to settlement, or even higher in some cases. That's all been dewatered, drained, tilled up, and oxidized. You're down into 2% organic carbon in silty clay loams. When your bulk density drops down to below about a gram per cubic centimeter, water can no longer go in, it has to go off. And so the floods we're getting throughout the United States that are not caused by rain, they're caused by the fact that we have depleted our soils of soil organic carbon. Because we are not taking advantage of that 10,000 foot candles of light to convert sunlight energy into resource. We have depleted it utterly. I calculated that one tillage on 6 acres of land that still had organic carbon in it would be equivalent to driving a car that gets 25 miles a gallon, 10,000 miles. Monstrous. You don't even hear about this in the balance on global warming and carbon production, but just the loss to oxidation of the fossil carbon and our soil organic carbon in the soil has been tremendous, mind-blowing. And this has really picked up since World War II. Actually, it was pretty much a spate of it in the 30s, but really since World War II, it's gone bananas. With our mechanized agriculture and our ability to really and our dewatering, we've successfully dewatered most of our land. You don't go off and go out. And when I was young, and in Illinois, you could go out, your feet could get pretty clogged up, 4 or 5 pounds of stuff on them, if you walked in the field. But all that organic carbon's gone. And that's it'll bake now in the summer if there's no water, if there's no rain, because we've lost organic matter and on and on. But the point is, the loss of soil organic matter, if you look in your Google map, down in Illinois or Indiana, and you look how much that's in row crop agriculture, that's an engine driving catastrophe worldwide, because we've taken a land that once had 7 months of life, water moving through a clean and constant temperature, constant rate of discharge, now is turned to filth, muddy, silty crap, sent to the tile system, or sent to the ditch, washed away, and there's no life on that ground except for 3 months a year when you have corn and bean doing something. But all reproduction, all the fecundity, the biodiversity, maybe 110, 120 species per acre is all gone. There's no more reproduction, no more nothing, just bean and corn for 3 months a year. The other 4 months of the north temperate growing season, it's empty, bereft of life. It just sits there and cooks. And turns rain to filth and sends it to New Orleans. So, water, that may be inconvenient, but it's like a stall spit on an airplane. You've got to be attentive to the realities. 10,000 foot candles here. By the way, when you had a healthy prairie and they were burning annually, you had maybe 80, 90, 100 flowering plants or flower type plants per acre. Each one of which had a geometry of insects, aphids, plant bugs, seed bugs, thrips, beetles, ants that were related to those plants in intimate ways. Our new book will articulate a lot about this. When you burn every year, only what you're doing is burning through the fine elevated fuels of the season. So the fire is a scudding fire. This scuds along, burning only through the fine elevated fuel, leaving below all the heat up. When the Hindenburg crashed, when the Hindenburg caught fire, only people felt no heat. They just died of neck injuries and back injuries. John Bacon, how many of you know John Bacon, the director of Indian Division Nature Preserves? One day he, who doesn't know John? Anyway, he was with a backpack, Hoosier Prairie one day, and they were burning over in Griffith, and the fire was getting to him, and he said, "Jerry, I don't know why I was so stupid." He said, "I should have just taken off the backpack and run like hell." But he said, "I kept the Indian pumper on." He said, "I found a low area and I just dove into it." And he said, this 30-foot flame just roared over him, and he felt no heat. Just a temporary loss of oxygen. When a prairie is healthy and burning annually, that fire is a scudder. Now, there's no heat going down, and if you're burning annually, then there's a lot of green still here and there left down in the little clumps and whatnot, even some standing up combs. It's a scudding fire. When you wait a year or two or more, now the fire is burning through the thatch from the seasons prior. It's wet, of different wets, different wetness. And the fire is a cooking, parboiling fire that grinds and cooks and parboils. And people who study insects say, well, if you burn after a fire, we get a depression in insects. Well, that's obvious because you've just parboiled them. But in those areas that we've seen they're annually burning, they are fecund with insects, fecund with plants, and all the substrates of plants. When you don't burn, you deprive whole gills of species of those flowers and those seeds of the season. The annual autumnal fire was the ancient rhythm. The extent to which a Western scientist with beards can think up alternatives to that, the extent to which we are beguiling ourselves and trying to outthink things. We'll get more to this later. So the annual autumnal fire, 100% of all accounts of fire in Illinois were annual and Indian set. There were no records of lightning fire, because the fire that was burning every year by the Indians could not catch on fire with lightning. We mostly had dry lightning in the summertime, when everything was green, and by the time it was fall, and you had the Indians would burn after the first hard frost, and so there was a consilience between the people and the place. Yes, sir.
I'm a CRP.
Yeah.
They recommend burning every 3 years. Why do they recommend that?
God knows. You know, the question was, why do they recommend burning in CRP every 3 years? Somebody just thought that up, pulled out of their butt. I don't know why. 3 years came from. They also have what they call the tolerable soil loss equation, or the T factor. If you can lose 5 tons per acre per year of soil, it's okay. Yes, sir.
What I was told was that the insects, you're supposed to burn 1/3 every year. Your insects jump.
That's the classic doctrine. I'm maybe the only guy other than Laura or Rika who studies insects with me who understands the annual fire thing. And Sandy's getting into it. But not many people really understand. So all of the literature, actually all the literature, the EPA, Fish and Wildlife Service, Corps will tell you other stuff. They'll tell you that wetlands are the great kidneys. That you're supposed to turn your rain to dirt on your subdivision or your corporate campus and send it to a detention basin that then twists it into a wetland. We're supposed to take all that crap. Somehow, what if you put nothing but poison into your kidneys? You wouldn't last long. So the wetland, there is no such thing as a wetland. Rain fell the same everywhere. It's just that different soils and different places have different ways of handling it. So the soils here and the plants here handle their water some way with a little bit of seepage from here. The wetland became a phenomenon in 1987. Well, actually earlier than that, but it became a doctrine in 1987 when they produced the Wetland Delineation Manual. And they developed a list of hydric soils. The Clean Water Act of 1972 said that, the writers said, the waters of the United States will be fishable and swimmable again. That was our idea. After Rachel Carson wrote her book in '62, it woke up a generation. We said, whoa, you know, that spawned the National Environmental Policy Act of '69. In '72, we had the Clean Water Act. '73, the Endangered Species Act. A lot of good stuff going on. Well, they discovered that the monosols of the prairies were hydric from a physical-chemical standpoint. That was politically unpopular. So they took all of the monosols and declared they were not hydric. Then they declared that waters in the United States were only areas that you could define as having so-called prevailingly hydric vegetation, quote, evidence of hydrology, not forgetting rain, and then what they call hydric soils. But you weren't allowed to consider the monosols hydric soils. So now wetlands became a thing in American doctrine and parlance and in lexicon that was that had an edge on it, that here was a wetland and here it wasn't. This is not something God thought of. This is something that politicians thought of because it was politically convenient. And so then wetlands were, and then this was difficult for people, I guess, to say that we had wetlands because then you can't tile them, you can't farm them. So then they say, well, wetlands are the place where you put all the filters. They figured the wetland, because you can create flow-through wetlands that can take in the summertime, say, phosphorus out and some nutrients. And of course, when those plants die in the winter, the phosphorus leaches out of the chloroplast, out of the mitochondria, and flow out of the system into the walnuts where we can't see it. But we're not measuring phosphorus in the growing season. Anyway, so wetlands are considered, and also wetlands were tied up, the word wetland at that time was tied up amongst the fish and wildlife people as places where you could grow ducks that you could shoot. And that was so wetlands were also regarded as a place where you could grow duck food and bring in ducks. So the wetland became a kind of thing that we were trying to work around as if it were something that was discrete from the upland. But all the native wetlands bore their water from here and from here. Not the way all your consulting firms design wetlands is they'll show you a little slanty thing that goes down and says, here's a sedge meadow, here's a wet prairie, here's a mesic prairie, here's a dry prairie. It's as goofy as Job saw, but I mean, it's just, that's what they say. The new wetland planting guide produced by the DOT in Illinois now still says that stuff, but their cross-section is even worse. It's just goofy beyond measure that in 2007, the year of our Lord, we remain so ignorant. But this is part of the politics of what we bring in. Money doesn't exist. Money is a creation of the Western mind. But so many things get linked to money that's unrelated to reality. We keep trying to confuse that with trying to be obedient to the laws. And so to go back to your question, I think, yes, sir?
I'm also on WRP. Where's WRP fit into that?
The Wetland Reserve Program?
Yeah.
Well, if wetlands are to be regarded as the places where you can have a free dump of nutrients and water, that means you deprive the place. I'm going to get to that here in a minute. That's where let's just get there in a minute. But there is, just try to keep in your mind that wetland wetland in common lexicon is an artifact of post-National Environmental Policy Act era, is what we understand it today. And it's not a real thing. It's a jurisdictional thing. It's purely jurisdictional. It's got nothing to do with the way the world works. If you have a fen, if you have Trail Creek Fen here, the Trail Creek Fen is running a lot of water, a whole lot more than a gallon per minute than those springs. If you were to build a subdivision, if the developer wants to build a subdivision up here in the hinterland, in the recharge area of Trail Creek Fen, and their consulting goes down, oh, here's where the wetland border is. You can build your homes all the way down to there. You basically deprive the wetland of all the water. So if you build those homes or that subdivision in such a manner as to not receive the rain and infiltrate it and make it clean going to the wetland, you destroy Trail Creek Fen without even stepping in it. So we can reserve wetlands, we can conserve them, we can save them, we can put fences around them, but we have to think about the lifeblood of the wetlands, which are up here. 1 gallon per minute leaving Trail Creek Fen is 520,000 gallons a year. That's a simple law. That's not something, that's not a political position. It's not an opinion. It's just arithmetic. It's a non-compressible resource. That's how hydraulic systems work in a car. You can't compress it, so once it's gone, you can't store it beyond the volume it already is. The only way you can store water is in the colloidal fraction of a real soil. So we've lost soil, almost all our soil in the agricultural land. So under the tree, if you're a little walking person and you step under the tree, you're now walking from 10,000 foot candles to 1,000 foot candles right under the tree. Right under the boughs of a great bur oak tree, you're going to get about 1,000 foot candles of light. That's still a lot of energy. And so what that light is fueling is little sedges, Carex rosea, Carex cephalophora, Carex radiata, etc. All those, they're the bunch grasses of the timber. They also have to be burned on a regular basis to stay strong and keep that little root mass, which is much smaller than the prairie root mass, because you only get 10,000 foot candles of energy driving the system. That's why the timbered soils did not accumulate organic carbon the way the prairie did. So in the little root systems of the woods, which are not as big as these, I'll make these big and make these small because you don't have but see, a lot of this light energy is driven into growing the tree. So about 1,000 of it can go into driving root mass of the little native bunch sedges. All right? In the woods, you had about as much organic carbon fixed every year in root system as was oxidized. The reason these trees, the trees in the prairies, tended to grow on the outwash areas is because the soil was more oxidized. The tree roots just cannot handle it out in a wet prairie. And because our mesic prairies were just, remember the mollisols were hydric. The tree roots cannot handle it out there. So the trees were limited to the morainic bluffs and outwash areas, or where you had maybe a little high cane or drumlin or something, maybe where it was a little low and there's plenty of water, but it was always moving through and well oxidized. So what kept that a salubrious system, so all that soil organic matter in there was a wonderful thing, just like in the prairie, but in the timber even more so because it's so well oxidized. Because those little bunch sedges could move also from condensation water in the night, there's plenty of water in the timber to feed, even in July and August, the soil fungi, the ectomycorrhizal fungi that was so important to the healthy growth of trees and to the healthy growth of many of our woodland wildflowers. When you graze out that bunch grass, I'm probably messing your picture up by moving back and forth, but when you graze out that bunch grass, now you've diminished the ability of root system to be produced below the ground, but you've not changed the chemistry of oxidation and reduction. So it continues to oxidize. Trees fall, the leaves fall down, the leaves, you get a little leaf litter now. But if you go into most of the woods today, and what happened was, when you had that good, wonderful, soil is like a living thing. Can you picture that wonderful colloidal soil fraction of soil organic matter moving water always down and always through and just always sustaining a nice, salubrious existence of living things in there? When you diminish that, that starts to go sour on us. We start losing living things. Yes, ma'am.
And that's but also in the soil, you've got the ori bodies, and you've got the springtails, you've got all the microfauna that's moving.
All the thrips, all the collembola, all the ants. I'll talk about that right now, just for your sake. In that, the specific heat of water water in general is the most wonderful colligative thing. The properties of water are just mind-blowing when you think about how water integrates into living things. An important aspect of water is what we call the specific heat. the ability to move or conduct heat, you know, in and out of a milliliter of water. Water, soil, you can take the soil moisture of a healthy, dry, gravelly prairie, okay, and if you'll get, in a good, healthy, dry, gravel prairie, because Laura and I are doing this, you'll get 60% soil moisture. In a fen, in a sedge stool, in a fen, you'll get 65% soil moisture. In a healthy woodland, you'll get 65% soil moisture. All that water, all in that system, not moving down, but keeps the ability of that water to change temperature ever so limited. So the temperature of that water stays very, very constant, ever so slowly changing over time. In fact, the water at say 30 centimeters in our landscape can actually be warmer in January than it is in March because of the pattern of heat movement in the groundwater. But water is such a wonderful thing. You know, it's just the way it handles heat. So all living thing. Now you are what we call endothermic. We are, because if we get cold, we put on a sweater. If we get warm, we take off a sweater. We sweat. So we're maintaining our body weight. Our metabolism is endothermic in that we sustain the temperature of our bodies so that our metabolism and all the living functions that we do, our brain, or all the stuff, our blood chemistry can work at a constant temperature. The Van Hoff rule in chemistry was pointed out, I learned back a long time ago, that for every 10-degree rise in centigrade, a chemical reaction will double. You can't be having this with living things. When you step into a cold pool on a warm day, there was a reaction because the specific you become now, your body becomes the same, becomes one with that water. The specific you are, you in the water, that water has a lot of temperature embedded in it, and you're just you. And so it's hard to thermoregulate for a mammal in very cold water for very long, you know this. Ectothermic organisms, the little collembola, all the little ants, all the little beetles, and all the little centipedes, and all the things that live in the soil, aphids, root aphids, are all ectotherms. Plants are ectotherms. The root systems of plants are ectothermic. They are carrying out their life in the temperature that is ambient to them. And so what we do today with wetlands is we have a root system, and roots are 120 million year old phenomena that began in the Cretaceous, always growing below soil where there's plenty of water, are all protostelic basically as an anatomical feature, very simple, not a lot of heterogeneity in root morphology. Their whole chemistry, their whole evolution has been living in the soil with good water, constant temperature, constant everything, stability. When we take for the first time in 120 million years and put water on a hot roof, a hot lawn, a hot field, a hot pavement, and superheat that water to 160 degrees, 120 degrees, and dump it into a wetland where the biologist says, well, that's where we have the great kidney, you now have pushing suddenly a whole temperature change into a system, the roots of which can't handle it. It defaults to cattail, reed canary, purple loosestrife, and a couple of other things that can handle catastrophic changes or fluxes in temperature. They have their own way of doing that. But very few of the 500 native plants to Porter County, almost no natives really have the ability to handle sudden temperature changes in water. So the idea of putting surface water that's been heated, forget the pollution in it, into our wetlands is catastrophic. That's why a lot of the better wetlands, where we get surface runoff from the woods now, and I'll explain that in a minute, or anything, there's a great apron of reed canary grass around the edge where it's sort of, you've seen this, you've been around, where there's this apron of reed canary grass it's defaulted to because you can't handle, the wetland plants can't handle that. And think of all the native insects that have an interdependence on a number of native flowers and plants. We have 500 native species of plants. God knows, even Blatchley didn't know how many beetles we had. that we're dependent on those floors, finding even more and more. But it's mind-blowing, the geometry of life that's dependent on our native plants. Almost all of which have been forsaken because of our wetland understandings and our wetland policy. I'm getting some grins, but this is you can't lose a prairie plant without losing probably 16 other things that we don't even know. An uninterrupted link to the soils, to the horizons below. So water could move. If you put water in a wet sponge and put that wet sponge on a dry sponge, the water won't go into the dry sponge until it becomes saturated. Because you suddenly change the consistency of the pore size of one area below another one. Even if it was sand, the water won't go there. So you have to have that wonderful sort of natural progression of soil into another, or layer, it's just all one living thing, like layer endodermal, ectodermal, mesodermal. You can't separate, you can't take the mesoderm out and still have an ectoderm and endoderm that's healthy. So that's what's been going on in our woodlands to grazing. We're slowly losing this. And there in the woodlands now, if you go in, you'll see that under the leaf mold, you now got clay. There's no soil. There is no soil. The only way to get soil back in our woods is if Carex pennsylvanica, Carex albicans, particularly the sedges of the montane, have the light levels that allow them to proliferate and restore root mass. And sedges, and those sedges will not proliferate until you get well above 5% of available light. This is 10%. They thrive in a range between 6, 7, 8, 10% of available light, a little bit more. Actually, some of those can thrive out in the prairie. Yes, sir?
I'm sorry, I did have a thought though. You have not mentioned the contribution of the megafauna to this ecosystem, but their impact is, I think, rather significant.
He talks about the deer and the bison and the elk that once were through here, just like the human beings, had a definite impact on the ecosystem, which we can get to in due course.
Okay.
But we had to think, Consilience is a big consilience, it's a big story. It's a big circle of life. And how you break into the Consilience story is a hard one for me. So I'm just trying to do it by degrees as we move up, so you can see the sort of physics and chemistry of what's going on in the soil, and then how some of the megafauna and human beings have an impact on that. So but the chemistry is, if you don't have the photoelectric energy here, you don't have the production here, and you start oxidizing, and our soils are going away in our woodlands. We have noticed, for example, that in the woodlands that are annually burning, because we have annually burned plots for 12 years in burned woods, right next to burnt woods that have not been burned, right next door, like out of Timber Hill, Iowa, in Decatur County, Iowa. The ants are very diffused. We looked at ants. Ants are almost non-existent, practically, in the unburned area, even the leaf litter ants. Out in the annually burned woods, we have 3 times as many nests, 3 times as many species. We have a lot more fecundity going on and more conservative ants. This is because ants, also being ectothermic, are dependent on strong soil moisture. Without soil moisture, throughout the growing season, you cannot have ectothermic inhabitancy. Our woodland wildflowers are about all that can persist in these days in our woodlands, because they mostly come on before the leaves have fallen, that have grown back on. And then, yes, sir.
Sorry. With respect to the burning regimen or the burning program, prior to anthropogenic effects, burns were far less common and were mostly mosaic as a consequence of lightning strike.
Well, that would be pre-Pleistocene. So you're talking about a Pliocene landscape, of which we know very little. But we don't know how long people were here. But we'll get to human beings in a minute, and fire. But the Holocene landscape of the Midwest, actually much of the world, was co-evolved with native people. So people who were native everywhere, all of whom had to have all of the resources, the diet plants, the food plants, the clothing plants, and venison plants, all within walking distance of where they lived. They had every native culture, had to manage the land where they lived so that as much biodiversity to supply their resources was necessary. And we'll get to that in a minute. But prior to the anthropogenic impact, we had a mile of ice. So, and then we had the interglacial periods about which we know very little about human occupancy. Archaeologists can only understand human occupation based upon evidence of what they find. Native people will tell you they've been here a long, long time, longer than archaeologists think. Perhaps even in the interglacial, they were back up. We don't know. What I have learned as a 58-year-old botanist, though, is what Wes Jackson once said a long, long time ago, was that scientists have a problem. They are quick to find mistakes in papers that were written 30 years ago. Maybe even papers written by themselves. They will even find mistakes written in papers written 20 years ago. And occasionally the one will be perceived in a paper written 10 years ago. But what scientists always have a hard time with is understanding that they're as infinitely ignorant today as they ever were. We have, if Aristotle could see what the fragmentation of scholarship if Francis Bacon could see what has happened to scientific method and the fragmentation of scholarship, he would be writhing and begging for forgiveness. He was a God-fearing man. Aristotle would leap into the lap of Plato and kiss his face asking for forgiveness for even having questioned the idea. So, I mean, we have taken scholarship, knowledge, scientes, and so fragmented it to where almost none of ourselves can talk to each other. Every science has its own patois, has its own everything, and it's killing us because the technological transfer just isn't there. I mean, it's a work. Shawnee, the great Shawnee leader, when he was still a young man, was visiting a Frank Galloway, who actually had a cabin on his property in Chillicothe, Ohio, and where he was born. But he had developed a friendship with this man, and he knew Galloway's books, and he liked him. And he actually sort of, well, the romance is that he kind of had an eye for his daughter or whatever, but we don't really think that. Anyway, once Galloway was telling Tecumseh that there were some scientists going to come down the Ohio. And Tecumseh said, well, they're scientists. And Galloway said, well, some scientists study the great bones of Louisville, some scientists study the stars, some scientists study the plants, some scientists study the animals, some scientists study the birds, etc. Tecumseh goes, all Shawnee do this. All Shawnee do this. It'd be nice if all people did this. In any event, so we're dealing with a Holocene age relationship between people and place. Dry lightning, the Rocky Mountains didn't start rising in our north temperate zone until about 60 million years ago, in the middle to early Miocene. The modern vascular plant, most of the modern genera are Pliocene in age. Most of those plants that co-evolved with the ungulates, or the grazing animals, which began their evolution 15 to 12 million years ago or so, somewhere in that area of Miocene, middle to late Miocene, also the earliest grasses, and the earliest plants that could be grazed off the top and still grow from the bottom up. This was well developed as an idea, if you will, by the Pliocene, which was the 2 million years or so prior to the Pleistocene, the ice ages. We do not really know what's gone on since then. Somewhere, things that archaeologists call human beings were supposed to be around maybe 1.5 million, 2 million years ago. We don't really know. I can tell you, having been around plants and some ants for a long, long time, there's a lot more going on there than we know. So we have always tended to look at people who are different than we are and think that they're not really like us. But the more you look at all living things, the more you see that they're a lot like us in the way they live, in the way they need a stable life, need a stable family, need a stable community within which to grow and have children. I will tell you this little story. I don't know, we're running out of time, but because I want to get to the end of this story. But when my son, I was a biologist when this happened. My son, when he was about 15 years ago or so now, when he actually did not have much of a sail, no keel, kind of drifting around. He decided, out of a great orgy of brilliance, he decided to join the Marine Corps. Well, okay, son, go join the Marines. But he did. We weren't at war at the time, and I thought, well, whatever. I was in the Army, I was drafted. It didn't kill me. Thank God it was during Vietnam. But when he left, when the Marine sergeant came to take him and his other buddy away who we went in with, how many of you been in the military? Anyway, my wife and I wanted to be with him a little longer. And so we went down into his bedroom, and being somewhat scientifically minded, we thought perhaps an archaeological dig would not be all that inappropriate, trying to discover evidence, statistically significant evidence that he had been to the local junior college. We found some trend information to that extent. But we also found little letters from little girls. You could tell little girls because they had an eye with a little heart thing over them, or a little something. And girls have a certain penmanship they hold in, even into high school, that boys lose. And these were they would use words that, you see, whenever I was little, even in the locker room, if you said, you didn't say pregnant, you said PG. There were certain things you didn't say. Well, girls now will say anything, and even in these written down letters. So we tried to not look at them. And then there's a lot of homework assignments that he'd forgotten to turn in. And one of those was wadded up, and we unfolded it. And it was in the 5-paragraph style of that they were teaching. They had to have, supposed to have an introductory paragraph, 3 expository paragraphs, and a summary paragraph. He had 5 clumps of words, and basically what it was a complaint. By the way, the Marine Corps made a gentleman out of him, and nothing. They handled a boy the way I could never have done it. I didn't recognize him when he came home. It was a wonderful thing. My wife was going to come home with tattoos, look like Arnold Schwarzenegger or something, in whatever Arnold Schwarzenegger movie is, you know, all that stuff. And it, well, anyway, but this one little homework assignment was basically a complaint. And we live in a subdivision in Glen Ellen, Illinois. It had a little school to which the kids could walk. We thought we'd ride. We found an old beater house that a botanist could afford back in 1984. And I am going to fix it up one of these days. Anyway, we found a house that a botanist could afford in this neighborhood, a little school, and we thought we'd arrived. You know, that was great. It had one lollipop tree, 2 poodle shrubs at the corner of the house, one tall, and then we had our own little drug-dependent lawnmower. What more is there in America? And but this letter said that it was basically a complaint that all the plants in our neighborhood weren't really alive, they just weren't exactly dead. He said they were more like prisoners of war or concentration camp victims, growing there until they died in the war to replace them, but that there were no children plants. Geez, he said the only free tree, the way he put it, was a cottonwood tree down by the school, behind which he probably smoked and read their own magazines with his buddies. I have this theory about the magazines because we found those, which I am going to get rid of probably tomorrow when I get home. And I was devastated as a father that I had raised my children in a place that had no children. And I realized that the way the world worked was that each new seed that falls with a combination of genes that the earth's never seen before or will ever see again. Just like each new child born of the womb is born with a combination of genes that the earth's never seen before or will ever see again. All born into a time that's never been before or ever be again. And if the seed falls into a habitat nearly identical to the one in which the parent is born, then it has the anatomy, the morphology, the physiology, and probably 1,000 things that Western science cannot see or measure that makes it strong in that place where it's born. Just like each new child born into a community of elders and wise people, and people who are thinking each of the other for 7 generations and all this sort of thing, will learn the ways of the elders, and with subtle, but they're also unique to all that have ever been, who will be, and with others of their generation, can respond to the subtle vicissitudes of changing times at the rates at which mountains rise and fall, and the earth can make itself new again. It is this capacity for renewal that we have designed out of our landscape. We've designed a landscape without children, or engineered children in the case of corn and bean. So the whole world is bereft of children. And our children today, as Richard Wood would say, are children with nature deficit disorder. We throw them into schools and into nature centers and try to teach them nature because they become more interested in methamphetamine or something else. Because the world really isn't a place where children are supposed to not be in contact with living things. Almost all things our children see today are things made by human beings, not by nature, including nature centers. Floyd Swink used to show his students. How many of you remember Floyd Swink? Oh, bless his heart. Anyway, he would show his students, he'd say, if you look at 40X, the razor blade, it's a razor blade, we make it. Good chick makes a good one. You can shave the face, it works nice and glistening, and fine, works well, at least works for a while. But if you look at it at 40X, it's clunky and bent a little bit on the blade. If you look at a cell at 40X on the microscope, it's beautiful. It's absolutely beautiful. There's only just perfection in all the cell. And all the cells around it are nearly identical to the one around it, but subtly different. Each one individual, but each one identical. Each one beautiful. At 400X, the razor blade's even clunkier and benter. Life is ever more sweet and more beautiful whatever scale you look at. Human beings cannot make life. All we can do is nurture it. We cannot make nature. All we can learn to do is learn its way and nurture it. Somehow we have to develop within our infrastructural aesthetic the idea that that's not beautiful. That only what is beautiful is children, and more children and elders, and life, and a circle of life, and living things, and become comfortable living with living things. We become too contemporarily comfortable living with dead things in emptiness. Even to the point where alive means long enough to where the landscape contractor is out of his contract. If it dies, you got to pay for it again. I was talking with a lady who studied Sue Savage-Rumbaugh, one of the authorities on the bonobo chimps. She studies their languages and knows, and of course, these chimps have homes. Their Aboriginal home is among them is on this peninsula on the Congo River, where they relate with the people there, and some of their words are common, and they can talk to each other to the extent that they have an interest in doing so. And their languages have evolved that way. Well, she was studying the languages, and she was asking one of the chieftains. She said, "When I leave, which would be a few days, would you all like to have a T-shirt that says Primate Language Learning Center on it?" And I said, "Sure. Why not?" She said, "Well, just tell me how many of you there are, and I will bring you some." So she figured it would be like maybe 35 or 40. And this actually put the elders into some consternation for a while, and after a period of time, she said, "Well, how many are you?" And they said, "Well, 500. And initially, she thought they were trying to scam her for T-shirts. And then she realized that they had no word for dead or alive. There was only the being of all who remembered. You could tell their story, you remember their smell, remember the song that she sang, remember how she felt when you were on her lap. They were still there. They were still part of the people. So their lexicon, their language, did not include the word dead or alive the way we do. Well, this is binary. You're either dead or you're alive, but you're not. There's no other intermediate zone. So language, the Germans have an expression that die Sprache ist der Spiegel einer Nation, that the language is the mirror of the people. And language of English is a very poor language for understanding this landscape. I've studied a little bit the Ojibwe, the Tawa, all the Algonquin languages. that relate to this language, and I don't know if we have time to get into that today, but understanding those languages is far easier to understand this landscape than in English. When we came to Plymouth in 1620, there were 26 language classes, at least, in North America. There are some language classes that are lost, we don't know them. A class of languages is a group of languages that include, like, for example, the Western Germanic class includes Dutch, English, German, Danish. That's a class. There were 26 language classes, maybe 100 different languages within the Algonquian class, which was the class of languages spoken here. But we have tried to take English in Western science in a compartmentalized, fragmented scholarship, and take English and try to understand everything from Plymouth to Monterey, from Barrow, Alaska to Florida City. It doesn't work. You have to get your mind back out of English and think about, what is the little Columba thinking? What is the little ant doing? All the things. We could go on about languages. Languages are so important because you get offended by words you hear if the person using them even doesn't mean to offend you, because words have this baggage. So language, it's hard for me to speak to you and make you explain things in one language or in language because it's just the nature of communication. I'm using words that you might mean one thing, maybe to somebody, to you, to me means a little bit else. My use of words tend to be a little more classic in their origin. So I'll maybe sometimes use words that are comfortable with me but are misinterpreted by somebody else. So you'll go away from what I'm talking about today, probably wondering what the heck he was talking about. Anyway, going back to here, when this rain is now falling on the woods, what would happen in the old days is the woods would go into the outwash, into the soil, and then seep out of the springs or work to the stream. So the water coming here was always the average daily temperature water. That's the beautiful specific heat of water. By the time the water is standing in the soil for a while, it reaches that annual daily temperature, which is around 53 degrees, 54 degrees Fahrenheit, and comes out here a constant temperature, a constant rate, and a constant chemistry. Pretty much. So the organisms of our streams, which if you read the early accounts, are just full of fish, mussels, all manner of benthos, just rich ectothermic organisms in there. This classic, just at Coffee Creek, they're neglecting Coffee Creek now, they're not burning it. But back when we were first restoring Coffee Creek, we were burning it, and we had restored a lot of the woodlands around there. The steel that would come up there would lay eggs, but the water was too hot for them to hatch. When we put all that discharge infiltration back into just that lower 10% of the Coffee Creek watershed, the steelhead eggs were able to reproduce. That's going to disappear because the geniuses out there now, for one reason or another, have decided not to burn anymore. It's mind-boggling. It tears my sanity, actually, at what we know that we cannot get people to understand. Anyway, so water coming out here was why we had such rich streams and wetlands. The only way water can get here and keep coming here every minute of every year, cool and clean and chemistry stable, is because it's here going in the same way. By depleting the rhizosphere of the woods, now rainwater in our woods, if you take your TR20 stormwater models or whatever, and you plug in woodland, you're going to get a curve number that's pretty low, because the theory is that woodlands don't generate runoff. So they're always underestimating woodlands and in the modern woodland in their stormwater models. Now the rainwater can go on, gets down to the clay under the leaves and starts washing away. So you can go out into the woods and see little trees no more than 5-10 years old with roots out of the ground. Now every botanist knows that a root grows in the soil. If you have a root that you can put your boot under, there is a catastrophic problem. It isn't necessarily erosion even that's occurring so much as it is gingivitis. The gum, the tissue is oxidizing away. All that wonderful soil organic matter that was in there is just contracting away from that root zone. And so the roots are now, and our trees of course are lignified. And they're staying where they grew. But the soil's contracting away around it. So that's why the roots are dying. And if you go out in the woods today, a so-called an Indiana Nature Preserve, and you'll see trees falling over. There's no great tip-up mounds anymore. There's what I call the dead tooth syndrome. Just a little bit of root at the bottom, just keels over. In fact, what we're seeing through all the unburned woodlands throughout Indiana is, in a few decades, I was just down at Brown County State Park yesterday, in the Ogle, whatever it was, Nature Preserve down there. There are great tall trees, to be sure. Joyce Kilmer would just love it. But it's nothing. It's open. It's over. There's nothing on the ground. There are no ants. There's no nothing. There's a little bit of, even the columbella are just a few here and there. There's nothing there. And what's going to happen is all those trees are going to come falling over and all in one decade because there's no soil left. And we're going to blame it on either oak wilt or global warming, rather than the fact that we have totally mismanaged those woods because we have this sort of Hudson River School idea of what a woodland is. This forest primeval that Durant would show a picture of after 200 years of neglect. And the idea of the forest primeval, a place where people aren't. We had grown in apartheid. When we were banished to the land of Nod, their east from having sinned, Eden was a place we were not welcome. And the word nature, the Indians had no word for nature, had no word for park. We have this idea that if we're stepping, and we don't do it well, I'll admit, step into a place where there's living things, we tend to wreck it. Because we don't do it, we do it to commodity extract something out of it, either timber or corn or bean, not to live with it. And so our record isn't good. So we lack confidence in ourselves that we can relate to nature anymore in a salubrious way. But somehow we have to reconnect and break down this apartheid between ourselves and the rest of the living things and become part of that. We'll learn again to burn, learn again to timber or to harvest all the things great grandmothers once did. More about that in a minute. So the rain now is being here converted to runoff. The rain here is converted to runoff. Here, the erosion can happen if there's any dissection because you start down cutting. You start cutting ditches and whatnot that lead to the river. Here, often you can also get erosional channels, even in woodlands today that don't have any storm runoff coming out, but just from the water that's on the sides of the woods. If you go into any woodland today, on the moraine, you will see dissections occurring and head cutting going up those ravines, not because somebody's dumping stormwater in it, but because the water is now flowing off the sides of the woods, down into that dissection and head cutting. If it had been head cutting at that rate for the last 8,000 years, we'd have base leveled to sea level by now. So what's also happening when water leaves is this. Every living thing eats where? At sea, Hopkins, Cafe. And it's mighty good there. Every living thing, plant or animal, must have these nutrients. These nutrients, carbon, hydrogen, oxygen, phosphorus, potassium, iodine, nitrogen, sulfur, calcium, iron, and magnesium, are crucial to all living things, every cell in your body, plant or animal. If nature were to allow these nutrients to leave, if water is going to leave with energy, it's going to take stuff with it. All right? So if water starts moving off the surface of the land, it's going to carry with it groceries. This is not a theory, it's not a political opinion, it's just what happens when water goes somewhere. So carbon can get to the top of the hill free, right? If carbon somehow were to flow down as organic matter, at least carbon, through carbon dioxide, can get to the top of the hill free. Hydrogen can get back to the top of the hill free. Oxygen can get back to the top of the hill free in the form of water, or even diatomic oxygen. Phosphorus goes where water goes. If water stays in the soil, phosphorus is there. Every living cell in your body needs phosphorus. The whole mitochondrial and metabolic system runs on ADP, ATP, moving of phosphorus back and forth. You have to have phosphorus in every living thing. When the plants die in the winter, and you don't, well, if you burn right away, there's no longer leaching. It just mineralizes out. But and if you're back into your clay, you get phosphorus back in the system. If you leach it out in the winter, because it will, when the cells die, the cells lyse, mitochondria, it all lyses out. The phosphorus then flows to the water. So if it flow through wetland that's cleaning your so-called stuff, phosphorus is flowing out, at least in the winter. Also, as treatment plants do not handle phosphorus. Water comes out clean, but the water is loaded with phosphorus. Only way phosphorus could get back to the top of the hill free would be if a flight of mayflies or a merchant came up and died up here, or a birdcraft or something. A geologic scale at which these things could be replaced. Potassium isn't as mobile in the water as phosphorus, but it also can leach. Has to stay always where it's been, in balance. Iodine has to be always where it's been, always staying in the soil, from every square inch, if the square inch is to be healthy. Nitrogen is complicated, but we have found a way to screw that up big time because it is so complicated. But nitrogen's every, doing all sorts of stuff, all out of balance. Sulfur stays in the ground. Calcium, of course, isn't going to be up here. If the calcium goes down here too much, you got to bring it back. All these things, iron, magnesium, if they leave the top of the hill with energy, with water, you're going to find too much of it down here where it pollutes this area, and the rest of it up here where the farmers have to bring it back, or where the system simply doesn't have it. And so our arrangement with this landscape has to be one in which the soil itself is strong enough to hold and keep healthy and keep economically viable C. Hopkins Cafe, if you will. To change that relationship is unsustainable. You can't sustain if you're pulling more money out of the bank every day than you're putting in. It's arithmetic. So our job isn't to avoid it, to develop different theories and political decisions. Our job is to figure out how to live with our land in such a manner as to keep all places where living things live healthy, including ourselves. When all of this, and of course, the bison and the elk in the prairie country, Indians would burn every autumn, right after the first hard frost. This is pretty much recorded. And this being the case, with it during the Indian summer, there would be palatable forage for the bison and the elk and the deer all winter long. Those bison with the big snowplow heads go under there, and they could just nice palatable forage. They're not interested in grazing the unpalatable chaffy crap from the season that hasn't been, that's not green. So they'll go off to where it was green, where it has burned. So Indians always burn right where they live. Partly in the winter there's different ways of, different peoples have different ways of dealing with it, but in any event, to keep the bison around, keep the elk around, you had to have forage. So you had, during the Indian summer, already the green would come back, because they would burn right after the first hard frost. By spring, you now had a strong sward of grasses for the ground nesting birds. When you don't burn, or you burn late in the spring, there's no good strong sward for the ground nesting birds. You can even burn into nests. Not to mention all the other things we've been talking about, because that snow has packed down the grasses, and you've now got crisscrossed stuff, thatch that can cook in parboil when you burn. I'm saying you shouldn't burn. If you haven't burned for a couple of years, you got to get started, but you got to do it. This is when all this is in place. You have consilience, if you will. Everything is jumping together and working together. But the key to this is, and I don't know how you deal with this as a scientist, but the fact is that this is all sustained by human cultural choices. We can choose to deplete C. Hopkins Cafe, or we can choose to sustain it, and we bear the consequences. This is just the way. When you don't, when the human beings are taken away, the land suffers and the people suffer. You read Colin Turnbull's book, The Mountain People. This is very, it's a microcosm of America. When you see a people that were so dependent on the lands were dependent on them, when they decided was it Nigerian government or I can't remember which state it was, decided to say that people aren't part of nature. They want to make a nature reserve of this great valley. They took the eat people out, sit them on the side of the farm. They became no longer the people focused on 7 generations and sharing and caring for each other and working in community, and they became narcissistic, living alone people, bickering with each other and seeking only after that which they would satisfy themselves for the moment. And the land suffered. Of course, went to weeds and started to go. So it's a wonderful, but it's a microcosm of America. If you want to read a good book, read The Mountain People by Colin Turnbull, written probably about 1975 or so. For whatever reason, we don't get theological or any other kind of way, the fact remains that in the North Temperate prairies, actually throughout much of North America, the only way these places got burned was by human beings. There was a place I went to in Canada, near Burlington, Canada, where the Niagara Escarpment breaks out right over Burlington there. And it was, as it sort of stepped down, there were these beech and maple and linden type things, young coming up, and old oaks with the open-grown limbs, now all shade-pruned, and looked like a typical Indiana timber that had not been burned. And I asked my friend, Eric Sharp, I said, why does this place look so fire-starved? This will not carry a fire. And he said, well, you know, Jerry, he said, there had been, from time beyond mind, a great flood in the Shawnee village here. All who have been taking out BTU, or wood, always for heating and cooking and building things. Takes many BTUs to keep people warm over a 6-month Canadian winter, just like it does in Indiana. So they were removing wood at a rate at which the grandmothers would always have enough women's plants, and the people would always have enough wood to sustain the people, but always enough light for the women's plants, always enough wood for the people. So they're a very maintained landscape. The people in consilience with the place. When the Haudenosaunee were removed, the land began to die. This is an old story. I have even a friend of mine, Herbert Dreisaitl, who lives in Hüberling in Germany on the northwest coast of the Bodensee. He's also a Swiss. And he said the Swiss government, they love the Edelweiss, they love the mountain meadows. And the way it had always been was Opa would take the cow up to the mountain meadows to graze from time to time. Of course, Heidi follows along, little Sandy O'Brien type pigtails, and just go up and Opa feed the cow, and coming always back down Opa with the cow. The Swiss scientists said, well, human beings are not part of nature. We had to take the Swiss farmer out of the mountain meadows. They took the Swiss farmer out of the mountain meadows. They grew up in shrubs, shaded away the mountain meadows, and they all started washing away. This is an old story all over the world. You read about this. We have to get outside this apartheid, outside this separateness we feel with the other living things, come to know them. I think all children should learn a group of organisms, butterflies, ants, plants, whatever, so they can relate to something in a group of organisms that won't lie to them, that isn't tenure-tracked, that isn't ego-driven, that isn't bound by doctrine, that simply flourishes when they're healthy, and they can learn to care for them, have empathy for them, and learn what it takes to keep them happy. Without a group of organisms, you're now dependent on academics who are always changing their opinions. Nothing wrong with academics. We apply a lot of the tactical approaches to learning that we need, but we need to somehow then get beyond that. Yes, sir?
I think this gentleman had a question too.
Oh.
In light of your concerns about the way we produce corn, I know that ethanol has been proposed by a lot of our politicians and others as a viable solution to global warming problems and the energy crisis. Would you care to comment on the recent popularity of ethanol?
Well, it sustains the farm program. There's nothing from a purely energy standpoint, it makes no sense. Just the actual growing of corn alone is so catastrophically unsustainable and at the commodity scale that it's unbelievable. Now, if you grow corn and are putting back again manure, animal manure or mulch, and are growing it at a human scale, then there's nothing wrong with growing corn. Corn's not the problem. It's when you grow 1,000 acres of it at a commodity scale, trying to get enough corn to get enough money to put your kids through college, if there's a family farmer left somewhere, then you need a lot of acreage at $5 corn, or whatever it is now. It's not going to happen, and the Farm Bill was last written, as I recall, when the gas was $1.65 a gallon. Inputs were unsustainable then. Now, for every gallon of gasoline that you burn growing corn, that's about 16 pounds of carbon dioxide that goes into the atmosphere that was fixed 250 million years ago in the Paleozoic. For every gallon you burn, it's 16 pounds of CO2. You know what, it doesn't dignify discussion.
No.
It's so goofy. You don't even know where to begin even delivering a response. It's the same way as this tree planting thing, that somehow we're going to plant trees and obviate our concerns over global warming. In order to plant a tree, which is a tree of this late Holocene era, you would have to plant the tree without using fossil fuel. You'd have to grow the tree, and maybe 60 per acre would be a maximum. They're planting 200 an acre, 500 an acre. You have to grow it in such a way that it could sustain enough light below so you don't get erosion. You'd have to then cut the tree down without using fossil fuel. And then you'd have to plant it deep enough to where it wouldn't rot without using fossil fuel. So that in the North Temperate Zone, planting trees, that's about as dumb as a box of rocks. And it's not to say that in the tropics, where they have a whole different soil situation, 365 days of growing season, and the nutrients are constantly cycling up through that medium, then a lot of the carbon is stored in those trees.
But there are no nutrients in the soil.
Yeah, they're not nutrients in the soil, they're all up in the trees.
Right, they're all in the living things.
They're all in the living tissue, but that's a whole other system. And so it's we get these things, and I don't know if these people who are propagating this stuff are just evil or stupid or what, but there's something wrong. There's a disconnect in our culture with reality.
It's this.
Yeah, she's part of
Somehow or other, they think that money is the answer. Money is going to make you happy. Money is going to kill you. I mean, the going after it, grubbing with it, it's just gonna kill us all. That's the unfortunate.
I know that you get into politics and the economy and stuff. My grandfather Wilhelm was born in 1877. A year after the Battle of Little Bighorn, I sat in his lap. The happiest moments of my life were free to sit in his lap and have him tell me stories. And of course, what he didn't have any coin money till he left home. The farm was just one that they just all grew themselves. We go into that, but you don't need money to be happy. You do need money to do all what we do, but the human being does not need money to be happy, to eat, clothe itself, or feed itself. It needs a community of people working together. And it needs a consilience of understanding of where the soil works as you're trying to bring nutrient and support from it. But you can't fake it at the end of the day. The downside, you've heard all this talk about sustainable development and low impact development and green development and green buildings and all this. The downside of unsustainability is it's unsustainable. You can't do it. I asked a green architect once. We do a lot of this work ourselves. We're trying to find a way to reconnect. But I talked to a green architect once, and said, would a Shawnee Ouija well get 50 points on a lead scale? No way. Didn't have enough systems to be good at it. Couldn't handle it. Let's don't get into that. That whole thing with architecture and our approach to things is a whole other discussion. But getting back to this, the other thing which I haven't, and then I'll leave, is the idea of beauty. We now think that is beauty, and that's why we sustain it. We love the lawn. We love the lollipop tree. The 7 poodle shrubs never ate. We love that. That's what our infrastructure is. I was watching some landscape architect show and talk about how the typical, the beautiful tree, what is the most, as if we're hardwired for the beautiful tree. And they showed these 3 acacia trees, a picture, one in the background, a great open tree, acacia tree, well imbalanced. There was a tree in the front which had a broken limb. And there was another tree over here which was a little bit misshapen and small. It wasn't quite the way. And obviously they said, which tree do you like best? Well, I would say, oh, the big widespreading one in the back. To me, it looked like an overgrazed savanna, you know, in Africa. But in any event, what we have a hard time in our what I call an infrastructural aesthetic, that which we think is beautiful, is we take that tree and we take the horticulturalist and we propagate that one tree throughout in the nursery, and then we sell them out as the perfect tree, or the perfect tulip, or the perfect whatever, the perfect Spirea Anthony Waterer, whatever it is, you know. And that's this perfection we put always in the 7s and 9s and 11s or in rows or whatever, and this is what we think is beautiful. But we still, even the people who think that's beautiful, still want to go to where there's nature, if you will. To where they're like the Tetons or the Okefenokee or something, where there's still life healthy, or Crock and Pine, you know, or Hoosier Prairie, or the part of Miller that burns every year or frequently. Those beautiful places. Because what you see, what is truly beautiful, what moves the human soul really, what we're really hardwired for, is that every single tree at Miller, if you stand there on the dune ridge and look, every one of them is imperfect slightly. Every one of them slightly off the little pattern. And that's what we see when we see beauty. When the beauty that chills you, the beauty that moves the soul, is that when every living thing is living in harmony, but every living thing is a little different from all the others. Just like each cell in Floyd's little paradigm. Nearly identical to the other, but subtly different, and always healthy. So the beauty comes in the uniqueness of all individuals in the system working together in consilience. Just like each new child is born, if loved, is beautiful. I was on an airplane the other day, and there's a father, came along with a little girl about 8 years old, and God bless her, she was probably technically homely. Well, she just was. And I looked at her, and her father was just loving her, reading to her, kibbitzing with her, they were telling jokes, and she was laughing, and but she was so gay and happy. And I looked at her, and as the flight wore on, she became progressively more beautiful. And at the end of the flight, it was the most beautiful little girl I'd ever seen. And she was beautiful because she was so loved. And I could not see her another way. And the landscape that is loved is a beautiful landscape. It's a landscape within which all the individuals within it are nurtured and cared for their own sake, for the sake of the columba, for the sake of this particular phlox plant that looks like no other phlox plant. If you actually look down at all the little rule anemones, they're all a little different. And that's what's beautiful. That's what we have to somehow reinvest in our psyche as to what is beautiful, is this consilience of all jumping together with our nurture and our care. And I would say, and as E.O. Wilson talks about consinity in the first chapters of his book, Consilience, consinity, and we have the little plant Gallium consinum, which means shining or beautifully all together. When everything is in complete harmony, it's beautiful. So when we have our relationship with our woods and our prairies and our wetlands, and the human beings are in link with it, not in a part type, but as a part of it, we have consinity, which adds the element of beauty. Without that element of beauty, we have technical understanding. When you have beauty, you have love. Without love, you cannot have beauty. Without beauty, you cannot have that which is loved becomes beautiful. That which is beautiful is loved. So somehow also into our understanding of the land comes not the various disciplines working together in consilience, but love and beauty. I mean, we'll just end it there. Yes, sir.
You say end it there, ending it there, or?
Well, you can ask a question, but I don't want to step on anybody else's time, because I know what.
We have time to take questions, or we can even have a break and come back with questions. We also will be serving food soon.
What time is it now?
A little afternoon.
I have to eat and go. Laura Rarica, we're working on a, if you know that book, Plants of the Chicago Region, the 4th edition, where we talk about the associates of all the plants? And the next book will have any insect that we see that has an intimate relationship with our plants will also be in it. Bird, thrips,
Laura
columba.
Rarica is working on it?
Huh?
Laura Rarica is working on it?
Laura Rarica is working on it.
I haven't heard about her for years.
Yeah, well, no, she's working with, we've been working on it like lickety cut, and we get the ants. She's become one of the nation's authorities on ants. And so we're bringing all this together. The new book will see that that the student will see that all these plants have also relationship with a whole geometry of other organisms. And that when you plant in a wetland restoration, as if they're going to live, these other plants, even if they don't die from hot water and compacted soil, they'll die from a lack of relationships. Yes, sir.
You're looking primarily at herbivores, or are you looking at
Any,
complex
well, we're not looking, for example, most of those spiders that sit randomly on any plant looking for something to eat, we're not including those, but we can't. Well, we're focusing on those insects that are nectaring on the vesicular hairs, or feeding on the pollen, or living on the roots, or in some manner, the thrips that work in the flower. Any animal that has an intimate relationship with a plant, a specific plant or genus.
Yeah, you're looking at commensals and symbionts in particular, or not necessarily?
Whatever application of relationship we want to apply to it, we're saying that this animal does this with this plant.
Oh, okay.
Whatever that is. Yes, sir. But Laura's over at Indiana New State Park right now, and I got to pick her up when we go over to Hoosier and spend some time working there from something John McComb wants to work on with ants. So I could eat a little bit, but I could answer a few questions, but I got to run. Sorry. I went on too long, but I wanted to get the part in about beauty and love, because at the end of the day, this is what the grandmothers and the grandfathers taught the children about the way. Yes, sir.
That to instill that, other than to try and instill in our children this beauty of commensalism, I mean, could you give us a list of a half a dozen ways to convey or to solve this problem? I mean, if there were 6 things that we could go out and do, to change the philosophy and the infrastructure, the thinking of this country or this world, and to overturn an economic system, I mean, it seems hopeless.
No. Study soil. Study soil.
Yes, study
It's
soil.
not hopeless. Study
Yeah.
soil. If you understand what causes living things to live, then, and put the emphasis there, like the book that you're talking about, and we talked about the soil ecology, because we study everything above ground, but if you remove those relationships below ground,
It's over.
then you essentially have nothing, and more research, and even to get children to even see, magnify the microfauna that's under, it's just breathtaking.
Here's what a children thinks a tree is.
It's breathtaking.
Root, stem. That's what a child thinks a tree is. There's no soil there. That's not, What I wish we could do is have, instead of having nature centers, we had well-managed natural areas. I mean, burned and well-managed, healthy, and then when the little ones, it's going to change with the age. You know, your 3s, and they're going to learn differently than your 5s, and your little 6-year-olds, and 7, they're all going to have different things. By the time they get into the middle ages, the adolescence, they're starting to think more socially learning. But let just kids go play, and maybe have people just sitting out on a log somewhere, carving, or knitting, or doing something, and then sitting there just to answer questions if a kid asks. And they will learn. Just playing and having adults around or elders simply there to answer questions and tell stories, not to teach them stuff. Somehow we have to, the earth's born again with each new child. So with every new baby that's born today, at this minute, we have an opportunity. And when I remember my wife told me once when I was thinking about going back after my doctorate, I said, well, Margaret, that'll take 4 years. And she said, well, because my GI Bill was running out. And she said, well, Jerry, sure. The 4 years will pass. At the end of it, you can have it or not. Same way with each new child. If we start now with each new baby, then in 15, 20 years, we'll have a whole different world. So I would say let's start focusing on those babies and start loving them and nurturing them, but not teaching them as such, but just become elders again. And then give them a landscape that's worth playing in. This is what we tried to do at Coffee Creek. We tried desperately to do this at Coffee Creek. Give them that every child who grew there, who lived there, could just go play in a well-burned, well-managed landscape that was full of rich and full of life. The corruption of that whole mess is beyond, it tears me apart. And then the lack of burning, it just breaks my soul in two to see the neglect that all that work went into, to see them just neglected for fire suppression and no babies. It was very depressing. Because I do believe in babies. I just believe that's where the world begins with each new child. And then what we do with it, that new baby. Yes, sir.
I spent some time in Florida a lot, and back and forth. And, Florida seems to be definitely out of sync. I mean, there's no question. I mean, this has been going on now for 10 years. The drought situation
Yes.
is the entire state.
Yeah.
And thunderstorms come up.
Right.
They don't rain like they used to. Overcast develops. No
Right.
rain, just a little drizzle.
No morning fog
No,
anymore.
it's dry. It's almost like turning into a Mediterranean climate. And everybody marvels, when they visit Florida, they marvel at the low humidity and all that kind of stuff. But the wildfires and the fact that the droughts were so long indicated to me is I don't know if they can pull out of this. I mean, what is this? The hurricanes that come through there, there's some minor relief, but the overall system seems to be broken down. I mean, people don't realize, even in Florida, how dry Florida is. I mean, you're in the agricultural section of the northern part, it's pretty bad. And it's bad in South Carolina, and then you get a minor, you get drought in North Carolina, and then it kind of is relieved north of the Ohio River, but it's just, we have to wait for nature to change.
Well, nature's not going to change.
No.
Physics and chemistry don't change. And only things that change is the choices we make. People. And so what we have to do is start working with babies in Florida as well. Now, I don't know. I mean, sometimes planes crash and a bunch of arms and legs around, you can't put them back together. I don't want to think that we're there in Florida. I'm a Floridian. I went to Florida State, Choctahatchee High
You know
School.
more about it than I do. You see it.
Oh, that's enough. Yeah, in fact, we're working with the Babcock Ranch, 19,000 acres down there. The new state thing they got with the state, 70,000 acres, the old Babcock Ranch. We're working with a wonderful group of people trying to repair bring little villages and whatnot to the old mining areas. And in fact, next week, we're going down there to a workshop with our Rocky Mountain Institute and some wonderful people trying to figure out how to bring water back to the Babcock Ranch anyway, and sustainable living there. We talk about locavores being part of the community. Locavores being those people who eat only local food grown there. And so there are people in Florida who are trying. The Southwest Florida Management District, there are people who are Neanderthals. The drain commissioner of Polk County was once asked, what about the water problem in Polk County? We don't have a problem with water in Polk County. We just have a temporary loss of water, a temporary loss of rainfall. the drain commissioner of Polk County.
Well, you notice this room right here, how many politicians are in the room? You know, I mean, nobody.
But here's what you do. Let me say this, though. The first farmer that first stood at Fort Dearborn in 1832, before the steel plow, he looked out over those great western prairies, wet, too wet to plow. Black Hawk was still angry. Let's say this 1831. There's no market, no government to administer it. If a guy had said in his ear, you know, this is going to be farmed rectilinearly from here to Denver in your lifetime, he had thought he was a nut. But it all happened by one farmer. And one farmer, and one farmer, and one farmer, as the economic imperatives of their day drove them in that direction of the choice they were making. And it happened. And so also could the restoration of our land occur one steward at a time, one baby at a time, by degrees. You handle the Hoosier Prairie, you handle the Beesiker Prairie, you handle it go on and on. You bring these places back to start restoring in, and by degrees, the only thing that's critical, what you need, you have to have the specific heat of water, you have to have water, soil, and the Aboriginal genetic memory of how to handle that locally, and the human relationship, if that's going to work. So a first priority, get back to your question, a first priority is to save every living bit of genetic memory that still exists in Indiana. That has got to be fair. You can't live without a toolbox. You cannot live without the knowledge, genetic memory of some place. There are whole counties in Indiana that don't have any plants and animals that remember Newton, say some counties, parts of them. So a first priority is save at all costs what we've got left. And then get beyond this academic stuff and start learning the organisms, care and having empathy for them, and start managing them, and then bring children into that, let them play. Let them pick the flowers. Let them make little baskets. Let them go just play. So we'll have enough fecundity, enough help in the system to let children just go play. And then whether it's over, whether the airplane is out of altitude experience and airspeed, we do not know. But until we hit the ground, we can keep rattling around in the cockpit trying to find a way to get this son of a bitch. Get this thing back in the air.
Are you a pilot?
No, sir. But
Well,
but I've been around all my life, you know. Yes, ma'am.
Can I just say one thing, and for this,
I see the shooting stars, and I can feel a sharp rock under my thigh, and it hurts, and I feel cold at night. He said, and I can feel, Dad. I like feeling things. And he grew up in a suburb, everything's 72 degrees, with no feeling. For the first time in his life, he felt something. Did you have a question?
Yes, I don't know if you could tell me what I could do about it. It's taken over my father's land, it's at Waha Lake, and
Largest lakes to try to kill off the Eurasian milfoil. I'm aware that it's a very difficult thing to eradicate no matter what you do, and I'm well aware that one of the problems that we have is all the erosion from the construction sites, and that's it's not this lake. This is just a small. In another location, our larger lakes are inundated with. I think you're familiar with milfoil problem. My question is, how do you feel about herbicide as a response?
I think if you're herbiciding in a lake that has this kind of landscape around it, you're doing it forever. Because this landscape right here, with every rain, is dumping Scott's dirt filter +2 into that lake every time it rains. Is because 26 mowings a year keeps the solar panels completely cut away. So you don't have any photoelectric energy going into the root system. There's no soil under there. And so all the rain falling, all this entire landscape will kill this lake because of the choices of the landscape around it. And the fact that we think that looks nice. And probably even paying to have the lawns mowed 26 times a year. And for every gallon of gas that comes out of that lawnmower, that's 16 pounds of CO2 that goes into the atmosphere. So this is the problem with the lakes, is what we see out the window. Once we get our landscape healthy, and the river, because we're sitting hot dirty water to these lakes with every rainfall. Once we fix ourselves and fix this landscape and learn to love it a different way, when we stop putting crap and corruption into the lake, then if we have residual problems and the native plants can't handle it, we can go in, even just hand picking the milfoil out, I didn't get it done. But until you fix the habitat, you cannot fix the inhabitants. You're just deciding on the stern of the Titanic which song to sing next, and arguing over it.
I agree with you. One of the problems is this is all being funded by DNR and approved by IDEM. We just go around in circles.
I don't.
In defense of what they're gonna use is sonar. From what I understand, sonar is all natural material. It's not a...
If you can get it out without polluting it more, then fine. But at the end of the day, the watershed of this lake, everybody who lives upon the lake needs to be reinvested in the lake. But right now, we take a beautiful Indiana lake in the LaPorte Lakes area in our glaciated country of Steuben and Elkhart County and St. Joseph County and even over to here and LaPorte. And we take those beautiful glacial lakes, people love them, like over in Shipshewana, whatnot, they're building these homes around them, and they kill them. They kill the very landscape that they loved.
Well, what killed them? The phosphorus coming off,
Phosphorus, temperature.
the line killers and weed killers?
Yeah, well, yeah, it's just, these glacial lakes, these glacial lakes had no outflow. They were ice contact depressions. So if you put a house here with a drug-dependent rug on it, right on the edge of the lake, rainwater that used to go in the ground and then seep to the lake, cool, clean, and calcareous, and then evaporate off the lake. And you take that and you suddenly convert that scenario to overland flow water that's hot and dirty and phosphorus ridden and God knows what else ridden, and you keep putting in the lake, what's the lake going to do with it? It's like continuing to ask your kidneys to have stuff go in but never come out.
Well, we have an additional problem. It's just not the landscape around the lake. You got the dolphins half a mile away, which are funneling.
Well, whatever the whole watershed of the lake is.
That's where the big issue is.
It's really the water, these lakes ought to have their own watershed commissions. Everybody who lives in that little watershed, whether it's 10 acres or 1,000 acres.
Ours is 5 miles.
Then you need to know, everyone who lives in that needs to know that they have responsibility for 1 million gallons per acre per year. If they're on a quarter-acre lot, they have responsibility for 250,000 gallons. If they have a 5-acre lot because the town zoned, they didn't want a lot of people around, and they zoned it for 5 acres, you can do more damage with 5 acres than you can with a quarter-acre if you don't manage it well.
Okay, and if you go on the web to www.savedunes.org, they've got the Dunes Creek watershed, they've got the Trail Creek watershed, they've got the Salt Creek watershed, and they're beginning to develop these watershed programs where they get municipal departments and personnel from the Parks Department to the Sanitary District Department, and everyone's realizing that this is an issue that has to have that type of addressing, and they're making headway.
By degrees, we're getting there.
Yeah.
Well, this is the drainage board that has the authority over watershed areas.
I mean, you have those people, the reality is the houses are there, but what can we do now to?
They have to change their landscape efforts.
Yeah, that's
right. And we stress, use phosphorus-free fertilizer. I mean, that's the big thing.
Well, then you have to have rain gardens. You have to maybe raise your mower and not have such a love of the totally anal lawn that's the 3 inches deep, but maybe allow one to be 6 inches deep to where you can have at least twice the photoelectric energy developing a little bit of soil up under there. In other words, just develop a different sense of what's beautiful. And this can come by knowing. Once you know, then you will see that as ugly, 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 and beyond ugly. But until you know, you cannot see it that way.
I come from an area where everybody put seawalls in. Everything was a concrete seawall. And now, I know it. But at that time, when people were doing it, they were saying, well, that was all right, nobody knew the difference. Now you see what everybody, they're putting glacier stone in front of the seawall, you know, or trying to get plants in front of the seawall.
My grandfather once said, son, you sawing that board off and it still ain't long enough.
It's against the law to have long grass over 5 inches in our city here.
There are subdivisions where it's illegal to have a garden, where you're not allowed to hang out your laundry.
Oh, yeah.
It's against the
It's against the
regulation.
law.
I like this. I like to see, as an old 60s person, I like to see this kind of, let's get after them politicians and get it right, you know, but just mostly get after the babies, so they come up understanding. And then once they understand it, then work with your neighbors. But you know, when Americans discovered that porpoises were being killed in tuna nets, Starkist tuna stock prices and their sales plummeted. Americans, once they know and understand, are good people and don't want bad stuff to happen. Most Americans just do not know what's going on. They're told lies by the government on carbon dioxide and corn and ethanol. They're told lies about our farm program. They're told lies about almost everything. And so what you have to find a way to do is just get people to know and understand. And somehow, and it's got nothing to do with Democrat or Republican. They're all on the same doctrine, which is basically a doctrine of collect, convey, and discharge, and commodity growth at all costs. Whatever that, and it's a lot of cost. So what we have to find a way to do is recoalesce communities that are growing their own food, growing their own, teaching their own children, letting them play, giving them access to the good opportunity, and get more local. Get back to a scale at which individuals are accountable within the community. Because right now, politicians are not accountable to anybody because they all vote for everything all the time and say they don't. And so there's no accountability. And when bad stuff happens, you don't know to blame the county commissioner, the state representative, the state senator, or whatever. There's no accountability. So as long as we're depending on those fools to help us see right, it's not going to happen because they're run by the plutocrats. The people who well, let's don't get into that. I got to run.